It's my great pleasure to have the first talk session. I don't know how this works. The second session of today, which has, as I said, this great mix of academia, industry, more experience reports, and more algorithms. And we start with Annette, who's talking a bit about her experience from kind of an academic side, I guess.
Yeah, thank you, Ragnar. I'm actually trying to mix all three aspects into one talk. So what I'm going to show you today is what we at Kaiserslautern University try to do in the space of offline first applications. So for those of you who don't know me, I've been part of the local first and CRDT crowd already, I guess, for around a decade. And together with Christoph Thyssen, who is a colleague from the Department of Biology, we set out to see how collaboration or collaborative software can be used in education. So he's a biology didactics professor, and at some point we sat together and were talking about state of the art in giving lectures in schools. So what many of you know and what is kind of considered a classical model is teacher-centered learning, where a person is standing in front of a blackboard teaching students how the world is supposed to look like. There's a lot of interaction between teacher and student, but not so much around students. What is kind of the other side of the coin, at least at the moment, is to have collaborative learning in an analog fashion, so using pen and paper and maybe other fancy materials where students sit together and work together. So they learn together. Teacher is maybe controlling what they're doing, but he's not kind of the center of focus. The problem with this approach, as you know, is that, well, it's analog, right? They work together on a piece of paper. What we actually want to have, maybe, also with new tools coming out and schools being able to use digital technology, is to transfer this analog collaborative learning into a digital collaborative learning. And at least in German schools, it's not so easy to get this working. And I guess my experience is representative, at least for many European and also international situations. Some of you might remember that there was this great initiative, this one laptop per child thing, where they wanted to get digital technologies out, equip schools and classes, such that every child would have one mobile device, one laptop, where they can share and work together in activities, share also internet connections and so on. Unfortunately, this project died in 2014 for various reasons, but I think it had this great idea. People go together, they work together, they can take their homework home, continue working, come back into school, sync, and see what the others have been doing. Maybe also work from home together somehow. So there is kind of a huge space of when work is done, how it is done, but it's still collaborative. Today's reality, so I have a kid in a school, or actually two kids in two schools. Today's reality, at least in German schools, is actually not reaching what we had back then, I think. So schools in Germany, in our hometown at least, have tablets, for example, and laptops, so you would think it's not so difficult to get some software onto these things and work. Actually, all the school books that we have been digitalized. So you get digital workbooks, you got school books, but in essence, they're just better PDFs. So with nicer scrolling functionality, and yes, you can take a pen and kind of scribble on your iPad, but then you have it kind of on your iPad or your tablet. So these digital material that is out there, that is sold by companies, is not collaborative at all. It's not intended for collaboration. It's intended for this, you do your single homework on your own, and maybe sometimes you sync with the teacher, but you never ever see what your classmates are doing that are sitting next to you, right? So this does not work, and I don't know if there are any plans to get this to work. There are, of course, many different collaboration tools out there that we all use. Problem with this is that if you look closely enough, even at university, the situation is that many of these are too expensive, especially for schools, and there are a lot of data protection concerns. Whether these are valid or not, I'm not going to discuss, but at least this is the situation that teachers and headmasters and so on have to deal with. Schools after the area of Corona, where everybody was at home, started to digitalize more. So some of them were already at the forefront, others kind of caught up. What many of them established were either some form of network file systems, which is at least some way of sharing your work with others, within a ecosystem that a school is allowed to use. The problem is these are typically too generic, and you typically also have no concurrent collaboration. So if everybody uploads their text document, you can see what the others are doing, but you're still not working together. What is out there with wikis and things like Moodle and Nextcloud is getting into this direction, but after talking to teachers, we figured out that these things are actually too difficult to handle because they're very general, and most of them don't support offline very nicely. So for example, Nextcloud, depending on how you open the file, you get copies. Yeah, well, good luck. And then you have 30 copies because you have 30 students, and every teacher is kind of saying, that's not what I'm going to use. So we sat down, and actually within the scope of a project, we decided that we want to get real collaborative environments for learning and studying together into schools, and together with BASF, who's sponsoring this project, and their Teens Lab, we're developing a software called the BASF Teens Labbook. What the software consists of is that we have a collaborative surface here where instructors can place experimental descriptions, students can place spreadsheets for filling up data, we have text modules, you can generate diagrams and so on. And the idea is that the students go to this Teens Lab, kind of get a tablet, work on these instructions, tick off the boxes as they go along, share their data, and in the end, they have a common session where they can kind of show how things go together, and if several groups, for example, do the same experiment, they can compare how different their results are. The requirements that we got, and that were growing over time, because at some point I realized, oh, it's actually cool that you can get collaboration, so let's see what we can get out of that. So we are supporting currently text, photos, videos, spreadsheets, and data visualizations. We get requirements for extending the software for new components, or for example, having little plugins for colorimetry and stuff like that. We have collaborative and also non-collaborative content. For example, one of the tasks that we got was that the task description, like the experimental description, must be non-modifiable. No student is supposed to change a single thing in there because otherwise, things could blow up. We provide templates for tasks. So for example, when you do an experiment and need to measure temperature, then you get a template spreadsheet that is already labeled correctly and so on. And we distinguish between public boards that are shared with everybody in a group, private boards where you can put your private notes on, and these script boards that contain the pre-contained material. This is mainly for convenience. This is how the specific project works. I guess not every collaborative software needs to have that. How is the system built? So in essence, it's local first, but it follows this flavor of local first, where you have a server that provides persistence and in general the access point or access location for the data. So we have a web server that serves the web application. It's a React application that does also data management using Redux. Material UI for the front end, and for synchronization, in the current version we use YJS that is connected to a WebSocket running on our server that persists the data into CouchDB, and we have another little media server where we store all the static content. It was not always like this, so I like to eat my own dog food in a sense that at some point we initially we started the collaboration layer with a concordant platform, which was done in a collaborative little startup that did not survive, but we learned a lot from how we did the data modeling there. So this was our initial starting point. Last year we switched to to YJS, and eventually we might consider also switching to Electric just to see how the data model within the application kind of changes. Now, when you start a project like that, it's very easy to kind of say, I'm going to do a little prototype and start working and so on. This has been in development now for, I think, almost 4 years, and it's developed mainly by students. So it's a very organic thing that grows over time, whatever that means. Once in a while, somebody needs to sit down and clean it up, I guess. Developing such a stack might be for many industry people here a thing where you think, yeah, well, just plug things together. We know how this works. My experience is that even students that like web development and want to learn more about it and even did a few projects are totally overwhelmed by that. Yeah? And so when kind of preparing for the talk, I was kind of looking back, what were the challenges that we were facing and are still facing? So where is the inherent complexity that we are shifting around, as Brooklyn rightly said? Let me start with the one that is maybe not so obvious. The UI is for us actually a huge challenge. I am not a front-end developer. It turns out that if you develop a web application that is supposed to run on laptops, on tablets, by different vendors, and is supposed to be accessible. So we also have had recently a user study with sight-impaired people. Yeah, so they also want to use it. I don't know where this complexity comes from, but it's simply not possible to maintain any software that kind of does what we're requiring. And so just to show one of the examples, if you open this application on a tablet, you somehow need to fit the keyboard somewhere, right? It came a little bit as a surprise. We were developing, of course, on the laptops, and we opened it on the tablet, and suddenly, like, half the space was gone by the keyboard. And then you start redeveloping and thinking up about where to visualize what. So it's really very difficult, and the problem is the shows. Yeah? So we have customers in a sense, and they are worried about this a lot, much more than I ever was. But yeah, there you go. The second challenge that we are facing is data model. So we are now already in the second synchronization framework. Maybe it gets better if we take a third one. But the problem is, I have the impression I know how CRDTs work. The problem is the way that we need to model the data in the application for the front end, for rendering and so on, tends to be slightly different from the way that I model my data with CRDTs. Then you have the transport data model, where you don't have the CRDTs, but kind of the stream and YJS of delta updates and so on. And then we have a persistence model, where you want to make sure that you persist stuff. And then you want to be able to debug things. Well, good luck. You're transferring your data between different views. At least for us, I have not found the sweet spot here. But maybe Peter has an answer for that.
Not at all. I just wondered if you could give a specific example of the challenge there.
Yes. So, as I mentioned, we have different components that we can use. We have a text editor, which is great because we can use YJS with the Quill editor, which is really a lifesaver for us, I guess. But we have other components where we do it the hard way. And one of them is a to-do list. To-do lists are that simple. Everybody knows how they work. So this is the example I'm showing you here. Yeah. So the way the to-do list looks in the application is that you have different items. You can also switch them around, which is not very visible here, but and you can append them here. You can tick them off, and you can change the content. The first student that sat down modeling the to-do list did it in a column-oriented way. Basically, I guess because Concordant didn't have nested CRDTs, so what we got were two arrays in essence, one for the status here, so whether it's ticked or not, and one for the description here. Two arrays meaning, if you put them together, then you have the status for the corresponding description. But as you all know, this means that you need to make sure that these arrays are always changed the same way, which means you need to have some form of transaction, making sure that if you add something to the one array, you also add something to the other, or remove, right? What also turned out to be interesting in that way was if you have two different CRDT objects, say, if you want to implement something like undo, which we're also supporting, you suddenly need to not only undo things on one object, but on a second one. So all the nice tricks that people play with stacks and so on are good, but they get more complex the more objects you have kind of in there. Another way of how to model this, of course, would be instead having one array and then for each entry here an associated map, JSON, whatever. and that has then these three entries, but this requires for us that we have nested CRDTs, which is possible with YJS, at least when I figure out how to use this in our Redux binding. Or to do something with references, which then means that you need to query many, many more objects, and this does not necessarily make your life simpler. Yeah? So this interaction might increase latency, and this is sometimes indeed observable by the user. It gets more interesting. So for the to-do list, we only have two objects or two CRDTs. We also have a spreadsheet, and there, so in the current version, by the way, for the spreadsheet, we have 5 objects working together. Yeah, so it gets more complex by the day somehow. What we figured for the spreadsheet was actually that semantics are also something that users are wondering, worrying about. They have certain ideas, and the ideas that our customers have differ from what we can often build with the CRDTs you have. So Brooklyn was perfectly laying the stage out for that. Yeah. So being able to have customizable CRDT semantics in some form would be nice. So with YJS, we are at the moment at least able to do everything we kind of want. But it's not so trivial. So one of the requirements that we got is that when we have a spreadsheet here and we have a concurrent edit with a remove. So one student is editing something, so think about they carefully put all the data in the spreadsheet, and then somebody is removing a part, and then it's all gone. You don't want to have that, so you want to default to the edit taking precedence over the remove. It's not so easy to build this with the CRDTs that we had. Okay, we managed somehow, just as an indication that it's really not so simple. Most applications that we figured when we did a small search, they go for the easier way regarding the conflict resolution. So for example, when we looked at Notion, if two users start here with a spreadsheet with 4 columns and 3 rows, one of the users goes offline and edits by adding here things into column A and removing column B. While concurrently another user added things here into Y. What I would like to have is that later column A and B are still there. Yeah? So they do this at the same time. Bob does it online, Alice does it offline. As soon as Alice goes online and synchronizes, what happens is that all her work takes precedence, which means that not only the entries in A appear, B is also deleted, and what's interesting is that also the column that was added by Bob and which Alice did not even know about disappears. Man, that's annoying, right? So you can, and I'm pretty sure that the developers tried their best to not come up with the semantics, because why would they? Yeah? So as you can see, there's a real inherent complexity. We had a paper presentation at the PAPOC this year where you can see kind of what cases you need to consider, and then start designing kind of the semantics that you want to have. But mind you, this is nothing I would expect an average developer to come up with. Yeah? In our first versions, we also had the default for removing, because it's just so much simpler, right? Second, as I mentioned, this has been a project that has been going on for a long time. And the more students we have on that, the better you want to automate testing and CI and these kind of things. So we do now some test-guided development. I had 2 very brave students that came up with the test suits over last winter. So we by now have pretty good, I would say, coverage of our things. We need to test for 2 things. We first of all need to test for the interaction tests, so based on the user stories, whether what we expect happens if I'm kind of offline working on myself and I press a button, whatever this button triggers should kind of happen. So this is the stuff that we test, but then we also need to test what happens in a concurrent case. So how does the state evolve, both with local actions and with actions coming from different users. So we there have now a test setup where we have 2 clients. We have the CRDTs here, and then we have kind of the materialized versions that we use within the application for modeling the application state. And then we, do different operations here on the CRDTs, and later on kind of check whether they are equal. Yeah? And you get a lot of tests to run for that. Our CI pipeline currently takes approximately 2 minutes. The longest test takes 19 seconds or so. Yeah? And yeah, there is space or so, but mind you, I'm not talking about this is the best that academia can give you, right? This is what the average programmer, yeah, our master students, I would assume, are average beginner programmers. This is what I get if you kind of let them loose and tell them, you know, try what you have. Yeah? And yeah, so this is kind of the state we're currently in. This project will be continued. We didn't put it open source yet, but it's supposed to happen within the next couple of weeks, I hope. So just to stay within the time frame and give us a bit of time for discussion. Writing collaborative web applications is fun and pain. It's very nice. You get very excited people if you kind of show how things work and, you know, have the synchronization and everything is really, really funny. Writing a substantial application, and I guess this is a substantial application with like 24,000 lines of mainly JavaScript code, is something that generates a lot of pain and also a lot of happiness. What we also figured out with our first test runs with the students in the lab is using collaborative software is non-trivial. You need to educate your users somehow. I know everybody knows how Google Doc works, right? So you can sit down and simply write your stuff. The more functionality you have, the more interesting it gets. And many, so one thing that we actually learned from last year's unconference in Berlin, that was also organized by Ink and Switch, was and which proved out to be very, very cool, is we needed to make the status of the application visible to the user. So right now we switch between green and blue depending on whether your data has been synced or not. And just giving the user this visual clue solved so many issues they had, because they would not understand, like, I have it here, why is it not there? Like, it takes, you know, a little bit of latency is a thing, even if you stand next to each other, if you have to go through the cloud at least. As an outlook, what we are currently planning to do, we have users. We can deploy this, so we use this in university classes nowadays. We are planning to deploy this to real schools, real students, so also scale things up. What I'm really interested in is to see interaction patterns. I don't know how people use Google Docs. I'm not Google, but we can ask or can look at how our students are using this and do some meta-analysis. You know, how many contributions were done by a specific person? Do they work one after the other? How fast is or how fast does somebody react on a wrong entry and tries to correct it? Do 5 people try to correct the same thing? How do they work together? Which also has some didactical concerns. There is no real software out for that, so teachers don't know how to teach with it. Yeah? And eventually we also need to give teachers the tools and hints on how to set up the right exercises. I guess we also should look a bit more into a systematic approach for data modeling. So right now we have this slightly messy setup with CRDTs and then Redux and so on, right? I guess this is what you need in some cases, but again, how do we model this? I know approximately how to model with CRDTs, a lot of people don't do. Access control policies. We have a very thin access control layer right now. We did work on access control previously. I think this would be a good use case where we can practice this. And also one thing we don't have right now, but I hope is easy to obtain, is peer-to-peer connectivity. Yeah, so such that it really works if they are sitting together in school and the Wi-Fi breaks down. I was once in a school where that happened. We did not use our software back then, but a different one. And man, it's a pain if you have 30 highly motivated students sitting there and there is no Wi-Fi for 3 days. We tried very hard to get our suit back then into a local first thing, but it simply did not work for several reasons. And I totally understand hesitant teachers nowadays if they kind of say, well, if I can stick with analog, paper works. I know how paper works, right? Going digital has a very specific risk, and I guess it's on us to reduce that risk somehow. Thank you.
Great challenge. So there maybe.
Hi, I'm Clemens Klockmose from Aarhus University. We are also building collaborative systems for high schools, have been deploying in high schools, and I would love to chat of potential collaborations. Just
would be great.
That. Yep.
Hi, great talk. I was wondering about the challenges of these different data representations that you mentioned, and maybe you could elaborate a bit more on that, why you need this kind of in-app view of your CRDT, because maybe I'm biased a bit, I guess, from like a reactive programming viewpoint. I would just expect that you basically can perform your edits directly on your CRDT and use that as kind of a single source of truth, and then in your user interface just have some kind of derived view of that you that you kind of bind that to your React interface and display that. So why do you need another data representation?
So we have that derived view. The thing is, so we have Redux in between. So we have this derived view, and then we have Redux for maintaining, in essence, this derived view together with the CRDT binding, so to say. Yeah, and this needs to be in one specific place. So whenever I update stuff, I kind of need to go through that thing and then need to materialize. For some of the application, like components, like spreadsheets and so on, doing this in an incremental way is non-trivial. Yeah, so if you materialize everything from scratch, it's much, much simpler, but the larger the data gets, the worse.
Thank you.
And Julian is a little bit spoiled from Rescala.
Yeah, thank you so much. This kind of field report from people really, especially working with student developers, is so incredibly helpful and valuable to see. I am as astonished as I am impressed that somebody thought to model a to-do list with 2 columnar arrays. It's the kind of thing that sure, yeah, I guess you could do that. But I would never have thought to try that. So it's great to hear how it went. So thank you. That part was really great. One thing I know I asked, but you mentioned in your slide with the triangle that there was a tension between the application, the storage, and the network transport, and you had different representations of each. You described the challenges of the sort of front-end part, but I was curious if you could elaborate like how the network and storage parts of that triangle also were tricky.
I'm probably not the... Yes.
Yeah.
I would like to tell you more about the challenges of doing the persistence here. The problem is we have not done that yet because it's challenging. So the thing is, whenever we have students starting with this, they want to see what is in the database. In our database, we are storing the YJS stream in essence, right? So the deltas, such that we can reconstruct things from them.
The encoded incremental updates, not the sort of materialized document.
Not a materialized document. And this is kind of difficult because then the students can't see what is actually in the database. And if you break invariants, so for example, we had one invariant that the spreadsheet needs to have at least one entry. The problem is that due to synchronization, sometimes the creation of the spreadsheet is not as fast as some other parts. So what we kind of do is that we create the spreadsheet and then we add one cell. But this addition of one cell is then synchronized. So the more students kind of open it on a tablet, the more of this one specific cell that we of course hard-coded to be R1, C1 appeared multiple times. Yeah? And then you kind of materialize from the CRDT and it breaks because the invariant that you have unique rows and columns is breaking famously. We had no way of going to that stream of data. I mean, it took us a while to understand what happened. Yeah, and I mean, just because we just coded it, it was kind of it should be that. Yeah, but
it works fine until there's latency.
It works fine until there's latency, but we had no way of kind of knowing what is actually now in this YJS layer in. What is the data that we kind of have? So we need to materialize that somehow. I think I recently learned that Databricks, I think it's Databricks, that they have this debugging view in the developer's view for the materialized CRDTs. And I think that's exactly what we needed.
I have built exactly this component, and I will show you what I built so that you can steal it.
Yeah.
Yusuf has one too. Yeah.
Yeah. So this is the stuff. This is the tooling stuff that
so
we all
good.
need, right?
Thank you so much. Yeah, and I really appreciate you unpacking that as well. It's super helpful to hear about. The other thing I just wanted to share was I went to a great talk by a guy named Sam Ritchie at Strangeloop last month. He is working on sort of a live coding notebook for learning physics and mathematics called Emmy, based on Sussman's work. And he's thinking about, he's in a slightly different context, but again, he's thinking a lot about these like collaboration uses, and like the professor is live coding, you know, the lecture so that students can see it, but he wants the students to be able to edit it at the same time so that they can experiment. And then how do you deal with all the conflicts? I was like, oh, this does sound like a CRDT problem. So maybe there's some opportunity to connect up all the people who are working on this and see if we can, you know, form some kind of a mailing list or something where people can chat about their challenges.
Yeah, maybe you can already set up. But actually, maybe have a short question for the audience. Like, who do you try to have students implement some local firsty application kind of thing? Is that something? Good. Quite a few people that did. So, were you experienced?
How many with GUI, with graphical user interface? Huh.
Similar experiences? Different, okay? So maybe we talk about that at some point.